Assalamualaikum warahmatullahi taala wabarakatuh. Welcome to another video on signal and system analysis. So in this video, I'm going to show you the solution to example 1 of chapter 1, of our course, which is introduction to signal and system. So in this example, the question said, classify each of the following signal into continuous time and discrete time, as well as analog and digital signals. Okay, so if we look at this figure, so we are given 4 figures A, B, C and D. So we need to classify each of this figure to either continuous time or discrete time, and to either analog and digital signal. So let's first have a look at or maybe let me just bring you up a little bit. Okay, so first let's classify the signal to either continuous time signal and discrete time signal. So let's first look at the characteristic of continuous time signal. So it says continuous time signal has amplitude. Okay, so the amplitude, or value, varies continuously, so vary continuously with time. For discrete time signal, the amplitude, only available at a specific point in time. Okay, so let's have a look at the figure down, and let's try to classify them to either discrete time or continuous time. Okay, so for figure number 1 of figure A here, we can see that the amplitude, varies continuously with time. Okay, so for example, at this time, this is the value of the amplitude. Okay, and then at this time, this is the amplitude. At this time, this is the amplitude. So you can see the amplitude varies continuously with time. Okay, so therefore this is a continuous time signal. For the signal shown in figure B, let me just enlarge a little bit so you can see properly. So here, let's say at this time, this is the amplitude of the signal. At this time, this is the amplitude of the signal. And then at this certain time, this is the amplitude. So the amplitude also varies continuously, with respect to time. So at this time, this is the amplitude. Right, so therefore this is also continuous time signal. And if you look here for question number C or figure C, the amplitude only available at a specific point of time. Okay, for example, at this time, this is the amplitude of the signal. But at this time, let's say for at this time, there is no amplitude because there is no this small circle, blue circle. Okay, so it only have an amplitude at a specific point of time. So therefore, this is a discrete time signal. Okay. Now for question D or figure D, it's similar to figure C. Okay, where you have amplitude only at a specific point of time. For example, only at this time, this time, this time. Okay, so in between this and this time, there is no amplitude, or there's no value because you don't have this blue circle, right? So therefore, this is also discrete time signal. Okay, and there's also a simple method to determine the continuous time or discrete time signal. Okay, by looking at the signal itself. Okay, a description of the signal itself. So if we just go back a little bit more up. Alright, so here we say, for continuous time signal, one of the characteristic is that we use the symbol T, to denote the independent variable, whereas for discrete time signal, we use the symbol N to denote the independent variable. Okay, so therefore, if you look back at our question here, just go down a bit more. Right, so we can see that For question A here, okay, we use the symbol T to denote the independent variable, okay, which is denoted by the horizontal axis or the x-axis over here. Right, so therefore this is continuous time signal. Similarly, this one we use the symbol T, so this again, this is continuous time signal. And this one we use the symbol N, okay, so here you can see x of n, so therefore this is a discrete time signal. Right, similarly for question figure D, we use the symbol N, okay, so we have x n over here, so therefore this is a discrete time signal. Okay, so now we go back to figure A, and now we wanted to classify whether this is analog or digital signals. Okay, so again, let me just bring you back up a little bit. Now let's see. Here we have analog signal and digital signals characteristic. So for analog signal, we say that the amplitude of the signal, okay, take an infinite number within the time range. Okay, as opposed to the digital signal, it has an amplitude that take only finite numbers. Okay, for example, maybe 0 to 1, or minus 5 and 5, 0 and 1, or minus 5 and 5, or it could be minus 2 and 3, for example. So it's a finite number of amplitude. So now let's have a look at question A here. We wanted to classify whether the figure A here is analog or digital signal. Okay, so we have seen the let me just quickly delete this so we can write on it again. So we have look at the definition or the characteristic of analog and digital signal. So if we examine this signal, we can see that it has an finite number of amplitude, right, within this time range, because at this time this is the amplitude, at this time this is the amplitude, at this time this, so it has infinite number of amplitude, okay, that varies continuously over this time range. Therefore this is an analog signal. Now if we look at figure B here, within this time range, let me just again delete this so we can write on it back. Right, so within this time range, we can see that the amplitude, okay, of the signal varies between two value only, okay, which is this, let's say maybe this is positive 2, for example, and this value, right? Let's say maybe this is minus 2. Okay, so you can see that the amplitude changes, okay, only between 2 and minus 2. So at this time the amplitude is 2, at this time the amplitude is minus 2, right? So therefore this is a digital signal. Okay, so we can see that this is continuous time and analog. This one continuous time as well, but it is digital, okay, because the amplitude varies between only two finite values. Now for this one, signal in figure C, yeah, again let me just quickly delete this. Okay, we can see that this is we have seen that this is a digital signal because the amplitude only available at a certain point of time. However, that amplitude, okay, has a finite value, okay, because at, let's say this is T1. Okay, at T1 here, let me just see if I can reduce the thickness. Okay, at T1, for example, this is the amplitude. At, let's say, T2 here, this is the amplitude. At T3, it has another value of amplitude. So the amplitude takes on infinite value, okay, over this time range. So even though it is discrete time signal, but it is still analog, okay, because the amplitude varies infinitely over this time range. Now if we look at the signal in figure D here, okay, you can see that the amplitude varies between only two values, okay, for which is this value. Let's say maybe this is positive 5, and this value, let's say maybe this is minus 5, for example. So at this time, let's say T1, the value is positive 5. At T2 here, the value is minus 5. So the value of the amplitude changes only between two values, which is positive 5 and minus 5. Therefore, this is again a digital signal. Okay, so it is discrete time signal and digital at the same time. This one is discrete time signal and analog at the same time. Okay, so that's how you differentiate. So actually the purpose of this example number 1 here, is for you to differentiate between continuous time and analog, and discrete time and digital, because as I have mentioned in class, and as well as written here in your notes, okay, sometimes some people will use the terms continuous time and analog interchangeably, but actually they are not similar. Okay, similarly, some people use the word discrete time and digital interchangeably, but actually they are not equal. Okay, so I hope with this example you can see the difference between these 4 types of signals. Okay, so with that I end this video, and I will see you again in the another video for another example. Thank you.